finite state machines. So what is the use of finite state machines and what are the major difference between Mealy and formations? Yes or no? After that, we implemented 101 sequence detection using Mealy with overlap, without overlap. We'll repeat again same thing. Clear? So we'll repeat again same thing. So now keep a heading 101 sequence detection using Mealy with without overlap. So without overlap. So now 101 I need to be detect. Okay. So 101 I need to detect. So for example, so some data randomly is coming. So in this is the data coming. Okay. So I need to detect 101 wherever 101 is there. How many times it comes? I need to count that. For suppose. So in this, by manually, if we logic we apply, this is a one time. Okay. After this is one time. Second time. After this is third. This is a fourth. Without overlap. This is without overlap. So no. So now this circuit I need to be implemented by using the Mealy machine. Whatever I told. Okay. So how I compare this? This is 101 sequence or not? How I check? How I check that one? First I check whether first one is 1 or not. After that, second one is 1 or 0. So after that, third one is 1 or 0. I check. So 101 sequence it is matching. So then we do this. So like that. So we have so here 4. So no, 4 101 sequence. Clear? So now we need to implement the same circuit using the Mealy machines. Mealy machines. So what is the statement I told? If n bits are there, n states are required. N bits are there. N bits are there. N states are required. So now here how many bits are there in 101 sequence detection? 3 bits are there. So how many states are required? 3 states are required. What are those? S0, S1, S2. 3 states are required. So now, so S0, if I will get 0, at starting only I am getting 0. So what I need to do? I need to stay there. So and I need to wait for 1. Yes or no? So if S0, 0 will come, I need to stay here. Output will be 0. This is a input. This is a input. This is a output. Output. Okay, because why I am representing like this means, so the final state missions, Mealy missions will be output will be depends on input as well as present state. Input as well as present state. That's the reason I am representing like this. Clear? So now, so if my S0 getting 1, S0 getting 1, this 1 is getting, that is our sequence. So no, sequence, that is our sequence number. What I need to do from S0 to, I need to go to the next state. S1. So input is 1, output will be 0. Output when it will be 1, when sequence detection is completed, then it will be 1. So now here S1 already we are detected 1, right? Already we detected 1. So now here we have 2 chances. S1 we have 2 chances. We can get 0 or we can get 1. After this S1, okay, first one detected. So we have 0 or 1. 2 chances are there. If 0 will come, that is our sequence, right? So I will go to the S2. I will go to the S2. When 0 will come, output also 0. 0. When one will comes, where I need to go? I need to check this bit is matching with this bit as matching. So then I need to stay same S1. If it is not matching, then I need to go to S0. So I need to stay here, same state. Okay. So 1 output is 0. Output is 0. So next what I need to do? So next here we already detected 1 0. Now we have possibility 1 0 1. Sorry, 1 0 0 1 0 1. Two possibilities are there. This is without overlap, right? In the middle without overlap, even so after this, okay, we get 0 or we get 1. We need to move to the reset. Getting 0, output 0. So 1 also will get 1, output 1. Both cases you need to go to the S0 state only. Clear? This is without overlap. Without overlap. Understand? Clear? Very simple. So with overlap, all the things are same. All the things are same. So with overlap, if you go with overlap, zero means 0, output will be 0. So if 1 output 0, it will go to next step. So then if it is 1, output will be 0. So same step. So if it is a 0, sorry, if it is yes or no, if it is 0, output will 0, will go to the next step. So after this, here we detected 1, 1 0, 1 1. So this is 1 1 matching. That's why we are staying in same state. Up to this S1 is same thing. Same thing whatever I explained here without overlap. When come to the S2, what happened? We already detected here 1 0, right? So now we will get 1 0. After that we get 0 or 1 0. After that we get 1. Two possibilities are there. So now, so what I need to do at S2, these last two bits I need to compare with these last two bits. Matching? No. So then last this one bit I need to compare with this last one bit. Some people are very talented. What they will do, right? First they will compare with these two bits. Then they will compare with this last bit to last bit. They will say matching, I need to stay here only. No. When two bits we comparing, you need to be detected two bits. You need to compare with two bits. It is not matching, then one bit here detected. One bit you need to be compared with this one bit, last one bit matching. No. So then where I need to go? No doubt. I need to go to the S0. S0. S0 output will be 0. Yes or no? That is not our sequence, right? 1 0 0 is not our sequence. So now if 1 will comes, 1 0 1 will comes, where I need to go? So last of these two bits, I need to compare with last of these two bits. Matching? No. So this last one bit I need to compare with this last one bit matching? Yes. So then where I need to go? So this one bit where it is? S1, right? I need to go S2 to S1. S1. Okay, when 1 output will be 1. That is the difference. Here both the cases we need to go to S0. Here we will compare. First two bits will compare. So then after that one bit will compare. If nothing is matching, we go to the S0. If matching, so whatever matching state, we'll go to that state. Clear? This is the state diagram. But this is not our final output, right? So what is the process? First we need logically, we need to think. We need to implement the state diagram. So from the state diagram, we need to implement state table. Binary state table we need to implement. So after that, we need to do the K-map, then the circle. This is the process. So now this one is implemented, right? This one is easy. I will take this one and I will implement final state, okay? State table. After that, binary state table. Clear? So can we go to the next step? Or you will want to note on this? Note down. Try to implement by own. You get these books out. Very well. Okay, have you cross-checked that? Okay, whatever. Here. Now we'll implement the state table. So how we'll implement the state table? State table I already told, right? State table. Present state, input, next state, output, right? Present state, what is the present state? It started at S0. Present state is S0. There are two possibilities are there. Input can be 0 or input can be 1. Next, so what is the output? If S0 is 0, present state is 0, so then next state also input is 0, next state also 0, right? If 0, where I am going? Same place, right? 0. So next, if present state is 1, what I need to do? Next state where I am going? If 1, I am going to S2. S1, sorry. S1. So now, present state S1, there is two possibilities are there. If S1 is 0, so then where I am going? S2. S2. If S1 is 1, where I need to go? S1 is 1, where I need to go? S1 only, same. S1. So then S2 will have two possibilities, 0 and 1. So S2, if S2 is 0 also, I am going to S0. S2 is 1 also, I am going S0. So this is overlap, non-overlap. So up to this, okay, non-overlap is same. But I need to be implement overlap. Okay. So then S0, so S2, if 0, where I am going? I am going to S0. I am going to S0. So S2, if it is 1, where I need to go? S1, right? S1. Okay. S1. So this is the only change will be happened. Remaining all the table will be same. If you keep here also S0, that is without overlap. If you keep here S1, that is with overlap. That's it. So now, so the outputs. Outputs, if you observe, where the output is 1, so in this condition only output is 1, right? Yes or no? After this only sequence completely detected, the output will be 1 here. So remaining all the cases it is 0. All the cases it is 0. Clear? So this is the thing. Yes or no? Say where it is 1. So when I will go to S1, output is 1. Other cases, output is 0, 0. Here also 0, here also 0, here also 0. Yes or no? All are 0. So now, so this is the state table with the S0. Yes or no? I need to be implement this one in the binary. So how I need to completely change into the binary? S0 need to replace with S0 will replace with 0, 0. S1 need to be replaced with 0, 1. S2 will be replaced with 1, 0. If S3 is there, S3 need to be replaced with 1, 1. Clear? So this is the thing. So I need to replace values with this. So if I will replace the values with this, so then how it will be? Binary state table. Present state So Q1, Q0, input, right? Next step Q1, Q0, then output Y. So after that, we'll represent the flip-flops. So flip-flops. So now, in place of H0, what I need to keep? I need to be keep 0, 0. 0, 0, 0, 0, two cases are there. 0 or 1 input. Yes or no input? 0 or 1. So then what I am getting? Next state also 0, 0. This is also 0, 0. Here, next state is 0, 1. 0, 1. Okay, outputs are here also 0, here also 0. So next, after this, so what we are getting? So S1, two states are there. S1 is 0, 1, 0, 1. So inputs are 0 or 1. So then what is the output we'll get? What is the output we'll get? S1, 0, S2, 1, S1. S2 means what? S2 means 1, 0. S1 means 0, 1. Output is 0 in these two cases also. So next 1, 0, 1, 0, two cases are there. S2, yes or no? So now inputs are 0, 1. So what is the next state? S2, 0, S0 means 0, 0. So S2, 1, S1, S1 means 0, 0, 1. Output here is 0, here is 1. Yes or no? So this is the thing. So now you need to be which flip-flop you need to implement this circuit. You need to decide. Any flip-flop you can take. You can implement that circuit. Any flip-flop. That is, flip-flop means what? It will store the data. You want to be implement in JK, you want to implement in D. So any flip-flop you can take. But when you are writing in an exam, so I will suggest you, if someone asks in the interview, I will suggest you that go with the D flip-flop. Why I am saying with the D flip-flop means D flip-flop, whatever next stage output is there, D flip-flop, whatever excitation table output also same. Next step is equal to D flip-flop. Simple. So you no need to be wait for excitation table. You need to draw for excitation table. So then get the values. It will take the process. So that's why. So take the D flip-flop. D flip-flop will be two flip-flops. We need to take two values are there, right? Q1, Q0. So I need to take two flip-flop. D1, D0. D1, D0. So now, so whatever this Q1 values are there, same. Let's just take Q1 values. I need to write here. So 0, 0, 1, 0, 0, 0. Yes or no? Yes or no? So now here D0, what I need to write? D0. What about the this state values? 0, 0, here 1, 0, 1, 0, 1. That's it, right? So this is the thing. Now one more case also there, right? The possibility 1, 1 also there, right? 1, 1 we are not writing anything. So no. If 1, 1 will comes, what I need to do? Is not there. Is not there. But 1, 1 will comes. What we need to do? This is 1. This is 1. This is 1. This is 1. But state will comes. No, right? Let K map you will implement, then you will lost. So let's implement the K map for D1. D1, I need to implement the K map. How many variables of K map I need to write? 1, 2, 3. These are the inputs, right? These three inputs K map I need to be take. Three variable of K map. Q1, Q0, I. Clear? So now we need to be checked. So D1 when it is high at only one condition. That is 0, 1, 0. 0, 1, 0 means 2. Yes or no? 0, 1, 0 means 2. This is 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. 0, 1, 0. 0, 1, 0 means this is the value. In this condition, it is high. After that, it is not have any value. Yes or no? But see, up to where we are written, this is 0, this is 1, this is 2, this is 3, this is 4, this is 5. But 6, 7, so we have those values, those states? No. What 6, 7 will be? Don't care. 6, 7 will be don't care. So what is 6? Where is 6 it is? 6 1. This one, right? This one. 7 is, sorry, this is don't care. 7 is don't care. So I need to be map. So when I'm mapping, so if I'm mapping these two, what way will get? What I will get?
6, 4, 5, 6, 7.
0, 0, 0, 0, 0, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 0, 1, 1, 1, 1, 0. This is 6. 1, 1, 0, 6. 1, 1, 1. This is 7. If I will map these two, what happens? So common is Q1 is common. No, 0 to 1 it is changing. So here what is the common? These two are common, right? Q0 I bar I will get. This is a D1 equation. Q0 I bar. This is also not required. Immediately you can write. It is high at only one case. What is the value? What is the value? So in this case, okay, in this only case it is here, right? Q1 bar is there, Q0 is there, I bar. You can take this one also. This one also you can take, but number of gates will increase. If you go with the K map, so then it will number of gates will be decrease. So this is a Q0 I bar. Clear? This is the equation. So now, so come to the D0. D0 I need to implement. See, don't cares, all the don't cares no need to be mapped. Clear? If you want, we can consider. If you don't want, we can ignore it.
6 and 0 permanently don't care. No?
Yeah. In this case, only 101 sequence. Okay. Only 101. Next, if I have 000 means, then it will change, right? According to that. Q1, Q0, I. So 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So now, where it is high? It is high at 1, high at 3, high at 5. 1, 3, 5. It is high. Yes or no? D. High at 1, 3, 5. Yes or no? 1, 3, 5. So 1, 3, then 5. 5 is this one. Yes or no? In this condition, it is high. Don't guess when it is 6, 7 are don't care. So how many maximum mapping I can do? 4, right? This 4 I can map. Yes or no? So if I will map this for what is the common? Q1 is not common. In the Q2 also, so Q0 is changing 0 to 1, but I is remaining same. So what is the value I will get here? D0 equal to I. Clear? D0 is I. I need to connect I to D0. So now we'll implement the circuit. Clear?
Mapping कैसे क्या होगा?
See, in the mapping, what you need to check. So when you are mapping this all the 4, these are all what is the common you need to check. Common. That bit should not change. That bit should not switch. So if you see Q1, so in this both are mapping, right? Here it is. In this case it is 0. In this case it is 1. This should not take. Okay. So now we have this Q0 and I. In this Q0 and I, this one is 0. This one is 1, which is indicated by Q0. So this one is 1. This one is 1. This is indicated by I. But here 0 to 1 it is changing. This also I should not take. Which one is take? 1 is same. That one I need to take. Clear? Anywhere same thing. Here I map to 2. So this is switching 0 to 1. But here these both are common, right? That's why both I took. Here only one common. That's why I took one. Clear? So if you map 2 variables, you will get 2 outputs. Okay. If you map 4 variables, you will get one output. Okay. One variable output you will get. If you map all the 8 variables, you will get output is 1. Direct one value you will get. Okay. If you map nothing, so then you will get how many variables of inputs are there? Those many. Okay. So you will know these things later. So based on this is 8 variable I told. Okay. 16 variable definitions will change. Clear? Means 4 variable came up. So now, so we'll implement the circuit based on this. Clear? Next, circuit implementation. So whatever we discussed is all things for this circuit implementation. So how many flops we took? 2 flops, right? So what are those 2 flops? D0, Q0, Q0 bar, D1, Q1, Q1 bar. See, they can represent flop side by side also. Anything connection should be important. Okay. So now, so what it is happening? So D1 I need to connect Q0 I bar. Q0 I bar. D0 I need to connect I, right? I connected directly. Here D1 I need to connect I bar Q0. Q0 means this one only, right? So this both I need to connect clock. I forgot it. This is clock CLP. Clock. Okay. So this is the connection. So after this connection, and one more, we forgot to write the K map for output Y also. We need to write the K map, right? Yes or no? Y. So take the Y also. How many variables are there? 3. So no, 3 variables. Q1, Q0, I 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So when it is high at only 5. Only at 5. Only at 5 means 101 this case. So after this it is not high, but 6 and 7s are don't case. So then I can map these two, right? If I will map these two, what is I will get? What is the thing I will get? If I will map these two, output y equal to what is the common?
Q1.
Q1, and in this what is the common? In this what is the common? Q1. In this what is the common?
One.
I. Q1 I will be the output y equation. Clear? Q1 I. Otherwise, okay. So you can directly write from here itself also. You can take, okay. So this one Q1, Q0 bar I. That is also fine. Or directly you can take here. You can map Q1 I. Q1 I. So Q1 is this one, right? Q1 I need to take, and I also I need to take. This two I need to give to the AND gate, and this will be the output y. So when I starting I told so next state combo. This is the next state combo. So then state registers will be there. Starting how I told. So I told like this, right? Next state combo. Okay. So then state registers. So then output combo circuit. So then this whatever state registers, feedback will goes and connected as input, and this is the input, and this input only directly connected to this output combinational circuit. This is the output. So when I am explaining, I told this one, right? So this is a this entire thing, whatever this AND gate, this inverter, these all things. Next state combo. Clear? So after that, this is a output combo. This one is output combo. So output directly connected the input, right? Yes or no? Output directly connected the input. So if input change, immediately output change. That is fast. But input change immediately, output changing, it can create the noise. So no noise in the output signal. When create the noise in the output signal, this is the problem. Clear? So this is the circuit. Getting? So definitely in the Millet machines, okay, output Y, you will get input I. Input I should connect it to output. Then only. So final circuit should comes like this. Then only it is correct. Otherwise, you did something. Clear? Any questions, any doubts, Millet machines? Any questions, any doubts? If this is clear, so then I will go to the more missions. More mission. After teaching that one, confusion will be more. Yes or no? Then we'll go to the more mission. So keep a heading. 4. More 101 sequence. 101. Without overlap. Without overlap. So now without overlap. Now I already told it when the differences when I am explaining. N bits are there. How many states are required? N bits are there. N plus 1 states are required. N bits are there. N plus 1 states are required. Means 3 bits are there. How many states required? 4 states. 4 states. So S0, Y0, S1 by 0, S2 by 0, S3 by 0. So then you should ask, okay, when Millet representing, you are not represented any 0 in inside, right? But here, why you are representing 0 inside? Why you are representing 0 inside? You can ask, right? Why I am representing inside 0? What is this 0? This 0 is a output. So in the Millet-Murray state, what is the output? Output depends on only present state. Present state. Yes or no? It will not depend on the input. It will only depend on the present state. So that's the reason when the sequence reach to S3, only at that time only output will be get. Other cases we will not get the output. Okay, final state only will get the output. Here the final state is S3. 3-bit final state is S3. So at that state only will get the output. Other state will not get the output. That's why I represented inside. If with input it is changing, I will represent with input. That what only we did in the Millet missions. Millet missions, with input it is changing, input along with state it is changing. That's why I represented with input. But here only it is changing with the state. So I need to represent inside the state. Clear? Clear? So this is the one of the difference. This is the one of the different Millet to board. Okay. So now we'll see how we'll implement 101 sequence. So S is 0. S is 0. Input we are getting 0. So I need to be stay in the same state. No doubt. Stay in the same state. Whatever Millet you will represent, same thing here also. 0, same state. You should not represent any output, input, outputs here. So next, S is 1. That is our sequence bit. So S is 1. So I need to go to the next state. Next state. Clear? So next state, okay, I am getting 0. So that is our sequence bit 1 0. So I need to go to the next state. So here 1 R. So here from the previous we get 1 detection. Now we have two possibility 1 0 or 1 1. 0 means I will go to the next step. That is our sequence number. Okay. So if 1 we get, where I need to go? So I need to be compare with this one with this one. Matching. So I should be stay in the here only. If not matching, then I need to go to the 0. So now as to what it is detected? 1 and 0 already it is detected, right? 1 and 0 it is already detected. So 1 0 already detected. After that we will get 1 0 1 or 1 0 0. Two cases will be there. So now 1 0 1 we are getting. So what I need to do? So 1 we are getting, we need to go to the, that is our sequence bit. I need to go to the next step. No doubt. So no. I need to go to the next step. If 1 will get. So if 0 will get, where I need to go? So last 2 bits, compare with last 2 bits. Matching? No. 1 0 0 0. Not matching. So this last 1 bit compare with this last 1 bit matching? No matching. So then where I need to go? From here to go back to S0. Okay. Go back to S0. Clear? So now here already we detected 101 sequence. So that's why output is 1. Already whatever required sequence we detected in this state. Yes or no? So that's why this is output is 1. So now again two possible cases we will get after this. 101. After this we will get 0 and 101 will get 1. Now this is without overlap case. Without overlap case, in this condition, people what they will do? These 3 bits I need to compare. No. Without overlap case, what we need to do? You need to check only this extra bit. Sequence is already detected, right? This sequence keep side. Only this extra bit you need to be checked with, okay, 1 bit, okay, state. 1 bit state is S1. This 0 is matching with this one. No, right? So then what I need to do? When 0 will come, I need to go to the S0. So in get S3, if 1 will come, this is matching with this one, S. So then I need to go from here to here. Getting? This is the thing. So when come to the melee, we are directly going to the S0. Even 0 will comes, 1 will comes. Okay. When now with non-overlapping. Overlapping case. So we compare 2 bit with 2 bit, 3 bit with 3 bit, 1 bit with 1 bit. So then according to that we went to the states. Yes or no? But when come to the Moray machine, so in the non-overlapping case, okay, after sequence detection, what is the extra bit is there? That extra bit only you need to compare, okay, without overlapping case. Clear? So now I will explain with overlap also, you will get clarity. Only this last thing will be changed. Other things are same. All things are same. So keep a heading 101 with overlap. So now S0 by 0, S1 by 0, S2 by 0, S3 by 1. Clear? So now 0 will come, so I will stay here only. If 1 will come, so I will go to the next state. 1 already detected, 2 possibility. 1 0 we can get, 1 1 we can get. So 1 0 will get. So that is the sequence bit. I will go to the next state. If 1 will get, I will compare with this. It's matching. I will stay in the same state. So after this, what I need to do? Here already we get 1 0. So now 1 0 next to 1 can comes, 1 0 0 can comes. So 1 will come, no doubt I need to go to the next step. 0 will come, these 2 bits I need to map with these 2, not matching. So this last 1 bit is mapping with this last 1 bit, not matching. So then I need to go to the S0, no doubt. So after this, so we detected here 101. So now we will get two cases 101. After this 0 we can get 101. After this we can get 1. Okay. So now this 0 we can get, 1 we can get. Now you should not check for one bit. Without overlap, you should check for last bit only. But here you should check for all the bits. Clear? All the bits. Last 3 bits you need to check with this last 3 bits. Matching? No. Last 2 bits you need to check with this last 2 bits. Matching? 1010 matching, right? So where I need to go from S3 to S2 when it is 0. When it is 0. So next, so here in this case what I need to do? This last 3 bit I need to map with this last 3 bit matching. No. This last 2 bits I need to map with this last 2 bit matching. No. So this last 1 bit I need to map with this last 1 bit matching. Yes. So then I need to go from here to S1. S1. When it is 1. That's it. Clear? So if you know the state table, state diagram, state table is easy. Clear? This is the thing. So now we'll implement this state table. So after that, you guys will implement the circuit. K-map and circuit. Yes or no? You know K-map, right? You need to try that one. So now we'll implement the state table. So state table. Overlap case will take. Okay. Non-overlap will be easy. We'll take overlap case. So same thing. Present state, input, next state, output. Present state is S0, S0, 0 can be there, S0, 1, S0, 0, I need to stay in the 0, 0, S0, 1, I need to be go to the S1, S1, so S1, 0 can be there, S1, 1 can be there, S1, 0, S1, 0, I need to go to the S2, S2, S1, 1, I need to be stay in the same S1, S1, so no, S1. So then S2, 0 can be there, S2, 1 can be there, S2, 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 1 is there, I need to go to the S3. 0 will be there, I need to go to the S0. 0, S0, this one is S3. So now S3, 0 can be there, S3, 1 can be there. This is the last two, only the change will be there. We will take this one. So S3, so if 0 will come, I need to go to the S2. 1 will come, I need to go to the S1. So 0 will come, I need to go to the 0 will come, I need to go to the S2. 1 will come, I need to go to the S1. This is the table. So here, so output will not depends on the input. It will depends on the state. When S3 is 1, S3 is present, so the output will be 1. In these two cases, it will 1. Getting? In these two cases, it will 1. So these two cases, it is 0. These two cases, it is 0. These two cases, this one will be 0. Getting? So only this S3 it will depends. This is the S3 state, output is 1. This is the S3 state, output is 1. But previously, we check input also. But here, we check only state. State is S3, output will be 1. Why we check only S3? Because at S3 when you are reaching, already you detected 101 sequence. Output is already detected. After that only you are doing the process. That one. Clear? This one you need to represent in the binary. Binary state table. So same thing. Present state, Q1, Q0, input I, next state Q1, Q0. So then flip flop, right? Output by then flip flop. So I'm taking D flip flop only. So D1, D0 because Q1, Q0 is not there. So that will generated by D1, D0. So now as S0 I need to be represent 0, 0. S1 I need to represent 0, 1. S2 I need to represent 1, 0. S3 I need to represent 1, 1. Clear? So S1, S0 I need to represent 0, 0. This is 0, 0. 0 can be there, 0, 0. 1 can be there. So in this condition, what is the next? S0 is 0. Sorry, S0. S0. So this is 0, 0. This is 0, 1. Here output will be 0. This one is completed. So next one is S1. 0, 1. 0, 1. 0, 1 will be there here. So now, so S1 is 0. It is S2. S2 means what? 1, 0. 1, 0. S1 is 1. Then S1 means 0, 1. Output is 0, 0 only. So then 1, 0. 1, 0. Then 1, 1. 1, 1. 0, 1. So now S2 is 0. S0. S0 means 0, 0. So S2 is 1. S3. S3 means
1, 1.
1, 1. So now S3 is 0. S3 is 0. S3 is 0. What is S2, right?
Yes.
S 0 means S2 means what?
1, 0.
1, 0. S3 is 1. Then S1. S1 means 0, 1. 0, 1. So these two cases 0. These two cases it is.
1, 1.
Output is 1, 1. Clear? So now, so this Q1 you need to be checked for excitation table. So but whatever next step will be there, same thing will becomes for D1. Whatever next step will be there, Q0, the same thing will comes from Q0. So then this one is 0, 0, 1, 0, 0, 1, 1, 0. So then here 0, 1, 0, 1, 0, 1, 0, 1. So now this one is 0, 1, 2, 3. Yes or no? 0, 0, 0,
Yes, sir.
0, 0, 1, 4, 5, 6, 7. All things are there. No need to be take any don't case. Yes or no?
Yes, sir.
So now we need to implement the K-map. Let's implement the K-map for D0. Sorry, D1. Try to implement parallelly. D1, D0, Y. So now K-map D1 when it is 1 at 2 and 1 at 5 and 1 at 6. 2, 5, 6. 2, 5, 6. This is 2. This is 5. Yes or no? So this is 6. This is 6. This is 7. Okay. So now mapping will happen. So how it will happen? Maximum I can map these two, right? Yes or no? So what is the common in these two? Common is
Q1.
common is Q1 is common. 0 to 1 it is changing. No. I0 Q0 I bar. Q0 I bar. Why bar? It is I is 0, right? 0 means bar. If 1 means no bar. So Q is 1, Q0 is 1, that's why Q0. So I is okay 0, that's why I bar. Clear? But one more one is missing here. Yes or no? This one or this one or so this one. This one is I need to map only one. In this, what is the common? Q1, Q0 bar I. Clear? So this is the equation for D1. D1 equation. So now come to the D0. D0 when it is high 1, 3, 5, 7. 1, 3, 5, 7. 1, 3, 5, 7. This 4 will be mapped. If this 4 map, what is the common in these two? Q1 is not common. In these two, what is the common? In these two, what is the common? It is Q0 is not a common. I is common. So D0 is I. Clear? So now Y. Y when it is high? It is high at 6 and 7. 6 and 7. So 6 is this one, 7 is this one. If it's both only there, 2 only there. Map this 2. What is the output be common? What is the common here? Q1. What is the common? Q0, right? Q1, Q0. This is Y. Clear? This is Y. So now I need to implement, based on this, I need to implement the circuit. So if I will go to implement, so let's take here only. So to go next page. So 2 flip-flops I am taking. D0, Q0, Q0 bar, D1, Q1, Q1 bar. Clock here, you will see clock. Okay. So now D1, Q0, I bar, Q1, I0 bar, I. Okay. So D1, Q0, I bar. First, let's correct directly. D0, it is I, right? I. So after this, I need to get I bar, I bar. After this, Q0 also I need to get. This is the Q0. Q0 is together. One AND gate will be happened. After that, Q1, Q0 bar I. So Q1 is this one. Q1, Q0 bar. Q0 bar means this one. Q0 bar. Smart like confuse. So now what we have I. So we need to tell directly I also. It's 3 together from AND gate. This both I need to give to the one OR gate. This output I need to connect to the D1. D1 I need to connect. Clear? So now, so again output also I need to be checked, right? Q1, Q0. So Q1. This one is Q1. This one is Q0. Both I need to connect to one AND gate. This is out. Now again, so when starting when I told what I told. Next state combo. State register So then output combo output. So this one is input and this will be comes as a feedback. So input is not directly connected to output. Here input is directly connected to output. No. In the middle it is connected. Here it is only depends on the state. The state of this registers it is dependent. Clear? So you need to compare with